All right, so our goals and objectives today are so that we can decide whether two quantities are in a proportional relationship by looking at a table or a graph, and to explain what a point X and Y on the graph of a proportional relationship means. All right, so to get started today, I want you to think about all the times we've used proportional reasoning in all of our previous lessons and courses. So, how did we use proportional reasoning in our previous courses? What's something that we did?
Reducing
Mm-hmm. Reducing
and enlarging.
images. What else, Levi?
And enlarging.
Enlarging. What's something else we did? What about how do we use it for recipes?
Graphing also.
Graphing. What about for making bigger recipes? Did we do that? What about mixing paint? What about scale drawings like on a map? Did we use those also? All right. So those are some ways. So give me an example of a ratio that we used. Give me an example of a ratio that we used.
2 to 3.
All right. What would the 2 represent?
Number of maybe blue paint.
All right. So 2 parts of something compared to 3 parts of the other. Good. So who can give me an example of a ratio and its 2 related unit rates?
Wait, what was the question?
What is an example of a ratio and its 2 related unit rates? What is a unit rate? Give me an example of a unit rate.
Isn't a unit rate like when you're comparing a ratio to 1?
Correct. So give me a ratio that's comparing something to 1.
1 red apple to 3 green apples?
Correct. So 1 red apple to 3 green apples. So if we use the other related unit rate, we would say what?
Like 1 red apple per 2, or like something per something else.
Correct. So we said 1 red apple to 3 green apples. What if we were talking about paint? Like 1 part red to 3 parts blue. What would be that ratio? That'd be 1 to 3, wouldn't it?
1, 3.
All right. Well, what if I said I wanted to use that to 1 cup? Like that would be 1/3 to 1 cup, right? Or no?
Yes.
Okay. So, basically what I was trying to get you to see is with Devin's 1 red apple to 3 green apples, we could also say 3 green apples to 1 red apple. So basically just taking that and flipping it over, all right? Or the reciprocal of that, okay? All right, so we're going to take that information and we're going to put it to use looking at this. So, Angel V, will you read that for us, please?
Yes. In earlier topics, you use ratio, rates, and proportional reasoning to solve problems. Play the animation to review.
All right. So, Vincent, tell us what's going on here. What's happening, Vincent?
We're trying to find out how much inches it would take in order to get from Los Gatos to Hayward. How many inches it would take from 5 miles, and we keep going up.
All right, go ahead, James. So, give me an example of that, Vincent.
What do you mean?
Well, what is 1 inch equal to on that map? Like each inch equals
5
what?
miles.
That's right, it equals 5
5 miles.
miles. And so in all, there were 8 inches from Los Gatos to Hayward, right?
Yes.
All right, since there were 8 inches from Gatos to Hayward, that means that there are how many miles in that distance?
40.
40. Will you read that down there at the bottom too, Vincent?
You can use ratios and proportion reasoning to interpret maps. For example, you can use the scale on a map to determine the distance between two cities.
All right. Great job. Let's go back and look at our next one. Read that for us, please, Kalia.
In earlier topics, you used ratios, rates, and proportional reasoning to solve problems. Play the animation to review.
All right. So looking at this, look at the bottom in the yellow. What's it say in the yellow, Kalia?
Oh, you can graph ratios as ordered pairs on a coordinate plane. When you change a photo proportionally, a line passing through the origin line lies on the diagonal of the photo.
Okay. So right here it's showing us that 9 inches of height is equal to 12 inches in width. So how could we create an equivalent ratio for this? Go ahead, Levi.
Create a equivalent ratio for 9 to 12.
All right. So like what could I do to create equivalent ratios using 9 to 12?
Divide both of them by 3.
Okay, that's right. So 9 divided by 3 is
3.
good. And 12 divided by 3 is
4.
good. So let's see if that's on here. Good, that's on there. What's another one we could come up with?
Right? Think of primary first-hand account. Everybody should know number 3. Nomadic means they do what? Move from where?
What's another one that we could come up with? If we multiplied, what could we come up with? What if we doubled this? Wouldn't, if we doubled 3 and 4, that would give us 6 to 8?
When
What were you trying to say, Devin?
never mind.
Okay. You sure?
Well, if we doubled it, wouldn't it be 12,000 and 16,000?
All right, now it would be if we doubled this. Yes, you're right.
Yeah.
But it wouldn't be 12,000. They just got a decimal right behind that first one, so it's making it look like that. That's a decimal, not a comma. So it'd be 12 to 16. You're right. Good job. All right, so we're going to go back and look at the next one. All right, Madeline, what's happening here? Make sure your screen's left on, Madeline. Go ahead, Kaylee. Vincent, tell us what's happening here.
We're we're separating how many miles for each gallon.
Correct. And so how did they do that?
They just divide it.
That's right. So read that down there in the bottom in the yellow.
What'd you say?
Read that down there in the bottom in the yellow.
Okay. It says you can use ratios to find a unit rate. For example, you can find a number of miles a car travels for every gallon of gas used during a 296-mile trip. The unit rate is 37 miles per gallon.
Correct. Perfect job. All right, so does anybody have a question about that? Yes or no? Doesn't look like it. All right, so let's go back, and we got one more to look at, and that's this man here. All right, so it says you can use the ratios and proportional reasoning to determine the side length of the reduced image. So looking at that, what's happening?
They're reducing the photo, trying to make it smaller.
That's right, they're reducing that photo. And so when they do that, we don't know the height, but we know the width. So how could we find the height?
Couldn't you see like how much it took to get 4 to 1.5?
Correct. So we could divide to find that out. And whatever we get, we need to multiply by 6, right?
Yes.
All right, so I'm going to do 6 times 4 divided by 1.5. Is that right? No, that's not right. Let's try it again. We want to do 4 divided by 1.5. When we do that, we're going to have to take that answer and divide it by. So we're dividing that by that original number. So instead of multiplying, we're doing 6 divided by 4. And then we divide that by 1 point. That ain't right. Let's put it in the calculator the right way. 4 divided by 1.5 equals this. So we're going to take 6 and divide it by that. Oh, man. So it's going to end up being 2.25. Another way we can show this is we can take 6 and divide it by 4 and get our constant. So 6 divided by 4 equals 1.5, and we can multiply that by 1.5. Is that the same answer?
Yes, sir.
Yes. All right. That way we don't have to deal with all those decimals places. All right, the next thing we're going to do is we're going to look at page 2. Okay, go ahead and read this for us, please, Braden.
In this topic, you will deepen your understanding of proportional reasoning and learn about proportional relationships. You will also represent proportional relationships with algebraic rules. Do you recognize any of these algebraic rules? What do the symbols in each rule represent?
Perfect. All right, so looking at this, there are 4 rules that they gave us. What do you think that first one is, Natalia? What do you think that first one is, Natalia?
Come on, the paper?
Yeah, on the paper. What do you think that first rule is? Like, what does the A stand for? Who can help her out? What does that A stand for?
I don't know what the A stands for, but I know what the W I think it stands for.
What does it stand for?
Area.
Area equals what times what? Good.
Length times width.
Perfect. What's the other one going to be? What do you think, Hagen?
Parameter.
Great job. So the perimeter is equal to 2 times the length plus 2 times the width. The next one is what?
Isn't it volume?
It is volume.
Equals length times width times height.
Correct. Equals length times width times height. And the last one, it says a half times B times H equals A. But that is the area of a triangle, because a triangle is half of a square. Okay? So I want y'all to write area of a triangle. I really want all this wrote down. But the area of a triangle is half times base times height. Or you could say 0.5 times base times height. Remember that these just mean that we're multiplying all of this together, okay? So we're going to use these and see if we can find out some stuff. Go ahead, Hagen. So looking at this, what I want to do is I'm going to give us some actual numbers to represent this stuff. So we're going to have numbers for length, width, and height. Let's go with 5, 4, and 3. And I want y'all to find the volume of this box. See who can get it first. When you get your answer, put it in the chat box.
What was the question again?
I want you to find the volume of this box that I just gave actual units of measure for.
Okay.
All right, Devin got 60. How'd you get that, Devin? What'd you do?
I multiplied 3 times 4, which gave me 12, and then I multiplied that times 5.
All right, Brooklyn got the same answer. What'd you do, Brooklyn?
I just multiplied 5 times 4 times 3.
Correct. And 5 times 4 is 20, and 20 times 3 is
60.
60. All right, James and Angel and Madeline, did y'all all do that similar?
Yes, sir.
All right. All right, so let's try the next one. The next one, I want us to find the area and the perimeter. All right, so length is going to be 7, and the width is going to be 6. I want us to find the area and the perimeter of this picture in the rose bush. James is just chilling. He's thinking. He doesn't know. James, try, my man. Try. You can do it. How do we find the area? Good job. Angel got the area. She said that length times width gives us the area, and the area is 42. And I think we're off on, I saw they were off on the perimeter. What's 7 plus 16, everybody?
I thought that was a 6.
Well, it is a 6. We got 6 times 2 and 7 times 2, and we got to add them together. 6 times 2 is what? Tamarian, what's 6 times 2?
12.
Good. What is 7 times 2, Sophia?
14.
Good. So we just need to add them together. So what's 12 plus 14? Good job. Madeline got it right. Madeline, what is the answer?
26.
Good. All right. And the last
Oh,
one.
I see what I did wrong.
All right. What went wrong? We can't hear you. Uh-oh.
I divided 7 by 6, and then I got 42.
All right. 7 times 6 is 42. And then we just got to define the area. I mean, not the area, the perimeter. So this is 6, and that's 7. So 6 plus 7 plus 6 plus 7 gave us 26. All right. And the last one we're going to do is we are going to use this one to find a area of the triangle. And so we're going to go with 5 and 10. And I want to see if y'all can come up with the area of the triangle. I think I'm going to get a lot of people. I'm going to trick y'all on this one. Look at there. I got one person already thinks they got the answer. They forgot something. Levi has the right answer. Let me see if everybody else can get the right answer. Good job. Good job. Got a lot of people getting it right now. Still waiting on Brooklyn. Good job. Where is Brooklyn at? Brooklyn, what'd you do first?
At first, I multiplied 10 times 5, but I went back and looked at it, and half of 50 is 25.
Good job. Did you do it any different, Hamarjane? Hamarjane went to sleep. Hamarjane, are you awake?
The same thing.
All right, good deal, good deal. All right, y'all are doing great. All right, so I'm going to take this off of there. Make sure that you have this written down somewhere. Is there anybody that needs some more time to write these rules down? All right, get it wrote down, Mr. James. A good spot to write that's on page 62.
I thought it was 63.
Correct, but I said a good place to write this would be on page 62 because it's blank. Does that make sense?
Yeah, I didn't write it on my book. I just wrote it on a blank piece of paper.
That's fine. All right, here we go. I'm going to give y'all about 1 more minute. All right, James, you got it, buddy? All right, moving on. Page 3. Marjane, will you read this for us, please, ma'am? Right here. I don't think Kamarjane can hear me. Read this.
Okay, I had that go for it. What do you want me to read again?
The part that I highlighted in the gray.
Do you remember that you can mix yellow and blue paint to make green? For this shade of green, you need to mix blue and yellow paint, and the ratio is 1:2.
All right. Here we go. Hey, I got some people saying their stuff's lagging. Just log out and log back in and see if it fixes it. All right, so looking at this, we got to find 5 more combinations. All right, so we're going to do those 5 combinations right now. So what I want you to do is I want you to look at number 2 on page 64, and this is what you're going to be, not number 2, number 1 on page 63, and you're going to use this to fill this out. All right. So I'm going to give you about 2 minutes to complete that table.
It won't let me type in the chat.
I know. I made it where you couldn't type in the chat because y'all started talking about stuff. So right now, everybody's supposed to be doing this. All right. So let's look at this. What's one that you came up with, Brooklyn?
Three to six.
Good. What's another one, Kalia?
8 to 16.
Good. What's another one, James?
I was thinking about 8 16.
All right. What is another one?
I said 2 to 4. I mean, 4 to 8.
Good. What's another one, Hagen?
I came up with 7 to 14.
Good. What's another one, Levi?
20 to 40.
Good. What's another one, Natalia?
6 to 12.
Good. Another one, Sophia?
4 to 8.
Good. Vincent? Help him out, Alora.
I have one.
All right, go ahead.
10 to 20.
Good. What's another one, Alora?
Oh, I have one.
All right, what is it?
I have one too. 3 to 6.
Good. Alora?
I got 20 to 40.
Good. Madeline?
I changed my mind. I think I don't know.
All right, so tell me this. Devin, how are you able to find out each one?
You multiply your first number by 2.
Correct. Whatever the number of cups of blue are, you multiply by 2 to figure out the cups of yellow. And so remember, this is in number 1 in your workbook on page 63. All right, so it says the coordinate graph shows that there is a proportional relationship between the blue and yellow paint. As the number of cups of blue paint increases, the number of cups of yellow increases proportionally. So, with that being said, in order to graph these, what we're doing is we're starting at 0, we move on the x-axis to the right, and then we move up on the y-axis. So we got 0, then we go 1 to the right, up 2. Next one, we start at 0, we go 2 to the right, and up 4. The next one, we start at 0, we go 3 to the right, and up 6. The next one, we start at 0, we go 4 to the right, and up 8. How would we graph 5 to 10, Madeline?
You would go, wouldn't you go over 5 and up 10?
Good. Hamarjane, how would I do 6 to 12?
You would go over 6 of 12.
Good. And how would I do 7 to 14, Brooklyn?
You would go over 7 and up 14.
Perfect. All right. Moving on to page 4. Kaylee, read page 4 for us, please, ma'am.
Like in this topic thing?
Correct.
Read that? Okay. In this topic, you will learn more about proportional relationships and how they are represented. The graph shows proportional relationships for 2 different shades of green paint. You can also use tables, verbal descriptions, and algebraic rules to represent proportional relationships. You will also learn about relationships that are not proportional. You will use your new skills to solve a variety of problems.
All right. So, looking at these, what is different about the blue line and the red line?
The blue line, its constant is 3.
Okay.
Like it goes up 1 and then it goes multiplied by 3, and then the red line is multiplied by 2.
Correct. So, which one is going to be a lighter shade of green? Would it be the blue line or the red line?
The blue line.
Why?
Because it has more yellow and yellow is a light color.
Perfect. Perfect job. All right. So, in closing to our overview, what are some other algebraic rules that we're going to see or that we have seen that were used in previous topics or courses? What other algebraic rules have we used?
is
Correct. Y equals K times X. What's another one?
it's like when we did like the moving car, didn't we do something about like gallons per mile or something?
Correct.
That particular one.
All right. So Y divided by X equals K. We've also solved for X in some of these. Some of us have used formulas to solve for the area of a circle. Some of us have not, but we're going to get into that a lot this year. All right, so there's all types of things that we've done. So what we're going to do to wrap up today is we are going to turn to page 64 in our workbook.
Mr. Martin,
Yes.
I was late today because I was having Wi-Fi problems. Can I watch the video you put out today?
Yeah, that's fine. But I would stay right now for doing this homework. That way you can get your work done on your that way you won't have any homework tonight.
Okay.
All right, so number 2. Read what number 2 says, Hagen.
Reinforce. Consider some of the proportional relationships you explored in the overview.
Okay. So what does A say?
As the number of gallons used increases, how does the number of miles traveled change?
All right. So what did we say?
We said that for every
You were starting. For every gallon of gas.
for every gallon of gas, there is.
How far can you travel for each gallon of gas?
Isn't it 5 miles?
No.
No, didn't think so.
Remember, they went 296 miles with 8 gallons of gas. So if we added another gallon of gas, how much further could we go?
Not quite sure.
All right. Who can help him out? How much farther can we go with one more gallon of gas?
We add 39 more.
Would it be 37?
It is 37 because 296 divided by 8 is 37. So for every gallon of gas, we can travel 37 more miles. All right. So the number of miles traveled changes by 37 miles per gallon of gas. All right. B said, what is the relationship between the number of inches on the map and the number of actual miles? This is what Hagen said a while ago. He said that 1 inch is equal to how many miles?
5.
Good. C says, in the original photograph, what is the relationship between the length and the width? Anybody know?
I'm confused.
All right. What are you confused about?
Okay, so what was the question? Can you repeat it?
All right. Looking at that photo right here, what is the relationship between the length and the width? Compared to this one and this one, they're both what? Starts with a P.
Proportional?
Yeah, they're proportional to each other.
I was like, huh?
All right, they're proportional to each other. So when it says what is the relationship between the length and the width, well, the constant of proportionality is 1.5. So if we take that 1.5 and we multiply it by the width, we can find the height. All right, and last but not least, numero trace. In a certain town, there are 2 houses for every 5 apartment units. Use this information to complete the activity. We want to complete the table. So if there's 2 houses, how many apartments are there?
5.
Great.
5.
Great. So what would that ratio be?
2 to 5.
Good. So what could we do to figure out the number of houses here since we know the number of apartment units?
We would multiply 2 by 2 because 5 times 2 is 10.
Good. Let's keep going. What would we do to find this one?
Multiply by 2.
2 times 3
Correct. Why are we multiplying by 3?
because 5 times 3 is 15.
Good. So 2 times 3 is 6. So we haven't been writing these ratios. Let's write those down.
6 to 15.
Good. And what would be the last one?
8 to 20.
How'd you get 20 so fast?
20.
Because 15
Because
is
it's going by
Oh.
5.
Hold up. Say it again.
if you add 5 to 15, it's 20, and they're just going by 5s, 5, 10, 15, 20.
All right. But to create proportional relationships, we got to do what? Don't we have to multiply or divide by both sides?
Yes.
All right.
Oh.
So
She's my princess.
what does that
she's
mean?
My queen. She just motivates
That
me.
means that the 20 is there because of 5 times 4 is 20 and 2 times 4 is 8.
Correct. And so we get 8 to 20. Now we got to take these right here and we have to graph them ourselves. So I want everybody to go and graph those right now in this area. It's on page 64. Oh, snaps. That wasn't supposed to happen. So tell me how I would graph the first one, Hagen. I start where?
At 2.
Nope. I start at 0 and go over to 2. Then I go up how many times?
5.
Good job, Hagen. All right. Kalia, how would I do 4 to 10?
Go up 4 and go up 4 to go over 4 and go up to 10.
There we go. All right. How would I do the next one, Kaylee? We got to start at 0 and do what, Kaylee?
Are you talking about the 4 to 10 one?
The 6 to 15.
Oh, 6 to 15. Okay, do you go over 6 and then you go up 16?
15, yeah, good.
15, I'm sorry.
You're right. You're following along right. And Braden, how do I do the last one? Where do I start?
Sir?
Where do I start?
Oh, for which one?
For 8 to 20.
You started. I can't really.
Don't we always start at 0?
No, wait.
Mm-hmm.
I'm trying to see the graph because
It's not showing.
me fully. I'm trying to remove the. Okay, now I see it. 820. you would start at 0 and go to
Do I go to the right or do I go up?
to the right.
Good, to 8, and then I go up to
20.
good. All right, so if we draw a perfectly straight line, we know that's straight so far. All right, and it would pass through our origin. But it says use your graph to predict the number of apartment units if there are 10 houses in the town. So if there are 10 houses, how many apartments would there be?
25.
How'd you get that so fast?
Because 2 times 5 is 10, and then 5 times 5 is 25.
Correct. All right, he said 2 times 5 is 10, and 5 times 5 is 25. All right, my boys and girls, that concludes today's class. Y'all can leave, and if you have not finished your work, make sure you get it done. It's open till 2:30. If you have any questions, you're more than welcome to ask. If not, y'all have a great day. Devin, are you still there?
I'm here.
All right, remember we have soccer tryouts on next Monday.
I was gonna try out, but I just don't want to be like the only girl. And
No, you're not going to be the
no,
only
there's a
girl.
whole
It's a whole girls team, Madeline. If you want to try
I know,
out,
I'm saying like Kalia, are you gonna try out? See, me and Kalia like best friends. We will be.
I don't know how to play soccer.
Me either. I've never played soccer before.
well,
I just want to do something this year since we're stuck at home.
are
Bye,
y'all?
Mr. Martin.
Bye-bye. Are you pretty athletic?
Yeah, I run around. I like to hit things. I like to kick things. I like to run. I like to jump up and down.
I would just go for it. I would try it.
Run around outside.
They might need you. I'd just try.
Hey, Mr. Martin.
Yeah.
While you're there today, if Coach West is there, can you ask him if I already made it through?
I'm pretty sure you have, Devin. Did Coach West talk to you?
Yeah.
Yeah, if he talked to you, you're already there.
He posted on his class, like his Google Classroom, and he said if you already made the team, then you don't have to come to tryouts.
All right, so you're good. You're good because he's planning on you being his goalie or our goalie.
Yeah, I played last year for him.
Okay, good. All right, so you're good. I wish you could have came to the Mississippi game with us this last week.
Yeah.
You were busy though, huh?
Yeah, I was busy.
I got you. That's all good. Well, James, you got any questions?
I have a question, Mr. Martin.
All right, Devin.
I forgot my Agile Mind login.
All right, so it's exactly the same. It's going to be Birdie D Hicks is your username, Birdie D Hicks, and then you're going to use just your regular password for your Google account.
Is the username, is it all lowercase?
Yes.
Okay.
All right. James, do you have a question?
I just wanted to show you something, if that's all right.
Yeah, show me, man.
Do you like Devin White?
I've heard. I mean, I know who he is.
Heck yes.
I have a signed autographed football card of him.
Oh, that's cool, man. That's awesome.
I mean, like, I could give you a penny for it. Like, that would. I think it's a good deal.
Yeah,
And
that's
then
awesome.
I have a signed autographed Buffalo Devin White.
All right.
That is.
Hopefully, it'll be worth something in the future.
It probably will be whenever like all this stuff that was out.
You're
Yeah.
gonna have like 5
That's gonna be
signed
worth a lot.
Kobe Bryant stuff.
Do you really?
Yes.
How'd you get that?
My dad's been collecting for like 35 years of his life.
Wow, that's awesome.
And he bought me some packs one day, and I got the autograph cards.
All right. Well, that's awesome. Well, y'all have y'all a great day, guys and gals. And I'll see y'all tomorrow.
See you tomorrow.
Bye-bye.
Bye.